we said that the second law of thermodynamics says that the entropy of the universe is maximized at equilibrium. So during a spontaneous process, so things that have a natural tendency to occur are associated with an increase in the entropy of the universe. And in the previous slides, we talked about practical ways of we look at it from a practical point of view where we can calculate changes in S in terms of heat measurements, right? So the question is, what is entropy really? We just defined it, right? But what is it in terms of, let's try to get a feel for what it is at the molecular level. Well, first of all, let's take a look at first at the statistical definition of entropy, okay? Entropy it can be defined as a measure of the number of ways that something can exist or happen. Okay, so let's consider a two-die toss. You know what a die looks like? Yeah, 1, a 2, and a 3, and so on, right? It's got 6 faces. So how many ways can you come up with a pair of snake eyes if you toss a die? Pair of dice. One way. They both turn out 1, right? 1 and 1. So you can get 2, right? So if your outcome is 2, let me tabulate it here. Let's look at the possible outcomes of a two-die toss. Number of ways you can get a 2 is how many? There's only one way. Uh-huh. How many ways will they add up to 2? One way. They both come up 1. Right? 1 plus 1 is 2. How many ways can your toss come out, give you a total of 3? So you can have a 1 and a 2. Or this one could be the 2 and the other one could be the 1. So 2 ways, right? You can either have 1 plus 2 or 2 plus 1. It will give you an outcome of 3. How many ways can you come up with a 4? 3 ways. What are those 3 ways? 2 and 2, 2 plus 2, or you can do 1 plus 3 and 3 plus 1, right? Okay. How many ways can you come up with a 5? See the pattern here? So it's 1 plus 4 or 4 plus 1 or 2 plus 3 or 3 plus 2. How many ways can you come up with a 6? 5 ways? Okay. How many ways can you come up with a 7? 6 ways? How many ways can you, what are those 6 ways? 1 plus 6, 6 plus 1, 2 plus 4, 4 plus 2, I forgot the 5. 2 plus 5, 5 plus 2, what else? 3 plus 4, 4 plus 3. So that's 6 ways, right? How about an 8? 7 ways? What are those 7 ways? Tell me. How do you come up with an 8? 6 plus 2, 2 plus 6, 3 plus 5, 5 plus 3, 4 plus 4. There is no 1 plus 7, and there is no 7 plus 1. Right? So it's not 7 ways, it's only 5 ways. How about a 9? 4 ways. A 10 would be 3 ways. So why do you think it's called lucky 7? That's the most probable outcome, right? Everything's random, right? So we say then an outcome of 7 would be a high entropy condition. It's the outcome that has more ways of showing up. Okay? So that would be a statistical interpretation of entropy. So the outcome that has the highest probability is a 7. That's the one we say, and that has the highest entropy. So entropy then we say is a measure of the number of ways something can happen. And when we're applying the concept of entropy to the way energies are distributed among the molecules, it turns out you get these high entropy conditions become overwhelmingly favored. Okay, and so that's the way we explain natural tendency for entropy maximization, the natural tendency for entropy to be maximized, as stated in the second law. It's all a question. It's all a matter of probability. And once we apply these ideas to atoms and molecules, it turns out that the high entropy conditions in these cases are overwhelming. You have overwhelmingly more likely to occur. Okay, so let's apply then this idea to molecules and atoms.